Hi guys, just another little test I've carried out on the circuit here. For this one it might be easier to use electron flow to explain what I've done here. And basically what I've done is the output, or the 0 volt output on the wave generator, which is only our power supply. Remember, we're not testing how much power this is consuming, we're testing how much power this circuit here is consuming. That there is basically one of these. When you test a circuit, you read your voltage and your amps coming out of this, and then see how well your circuit's doing. You're not really interested in how much everything behind that is consuming. As soon as you turn on a power supply, it starts to consume current, whether you're drawing off it or not. What we are looking at in this circuit is the current we're pulling from the power supply and what it's giving us back. So what I've done here, I've eliminated the 0 volt output, just going off the positive output of the wave generator into the positive side of our circuit, and I've removed this just to eliminate some confusion. That 0 volt output of course is connected directly to the 0 volt input of the circuit. So all we're doing now is coming directly off the negative side of the battery, and my meters are all turning off, and we're going through our meter here and into the negative side of the circuit. So the test that I've done here is I have a cap. I have the red lead of this meter here hooked to the negative side of the battery. Now this will be reading milliamps, as will this one. So coming from the negative side of the battery here with our red lead, going through out of the meter, and we're going into the positive side of this cap. On the negative side of the cap, I'm coming out with a diode that is also joined to another diode in the opposite direction. So what this is allowing to happen here, and for us to see, is the electrons that are flowing out of the negative, or true current flow, that goes through this meter and into this diode here, which is hooked to the negative or ground side of the circuit. This other meter, which we have the positive side hooked onto the negative side of the battery, is going to the positive side of the cap. So in order for that cap to get any charge whatsoever, the negative flow going into, or the electron flow going into the cap, has to be at a higher potential than the battery to make this a positive terminal. So it's a potential difference. So because we're coming out, our flow is allowed to carry on through the circuit in one direction, and then the flow coming back from the circuit will go through this diode and into this cap. I have an LED on the cap to supply us with a load and a stable voltage, and we can then measure the difference we have between the negative on the cap and the negative on the voltage to see how much higher, or the potential difference we have between the two. So we actually have to get the battery voltage plus about 2.5 volts to light this LED up. So I've drawn the part of the circuit that we're going to be looking at here. As you can see, we have our cap, our two diodes that goes to the negative input of this circuit here, and of course back to the negative side of the battery. So having just that hooked up like that, there is no way in hell coming off the negative side of the battery itself this cap is going to get any charge at all. So remember, this potential here, as far as a negative potential goes, or true current, has to be higher than the battery in order for us to light up this LED. This meter here I have hooked up to the negative side of the cap here, and I have the other end of the probe stuck into the negative side of the battery. That's going to show us our potential difference between the two negatives. So like I said, in order for this to light up, the electron flow going into this cap must be greater than the electron flow coming out of the negative side of our battery. And that extra flow is going to be from our circuit. So electrons flow out of here, go through this diode into the circuit, and then when the circuit switches, electron flow will come back out, go into the cap. Our negative on our battery will become a positive potential, because using conventional current flow, you could say that this will be pulled down below 0 volts. In actual fact, the electron flow going back into this cap has to be higher than the electron flow coming out of the battery. So we'll switch it on now. As you can see, we've got 126 millivolts in the cap. This is the meter that is from the negative side of the battery going to the positive side of the cap. That will show us our current, and of course this meter here is coming from the negative side of the battery, going through this diode and into the circuit. So we're basically using the circuit as an electron pump. We're going to put so much electrons in, and we're hoping to get more out. Now, we probably all think that's pretty impossible, but I'm going to show you right now that I actually believe it to be very real. So we turn the circuit on, our LED has come on. So that already indicates to us that there is a higher electron flow going in than what's coming out. This meter here we will switch on. Okay, this is the current at the moment that is on this lead here going into the circuit, and that one there is the meter I have from the positive of the cap to the negative of the battery. So as you can see, our little LED is quite bright, and that is because the voltage difference between the negative side of the cap and the negative side of the battery at the moment is 2.92 volts. So that's 5.88 milliamps is what's running this LED at our 2.919 volts. And what you have to remember is this voltage that we're getting, because of the way we've hooked the circuit up, is above the voltage of the battery. So we actually have to achieve 2.92 volts plus the battery voltage to get that 2.92 volts in this cap, the way the circuit's hooked up. So we have 5.85, and that is on the return flow, the electron return flow back to the battery. That is also running the LED. And we have 5.86 going into the circuit, and as you can see, we are still running those LEDs, and of course our orange one, which I'm calling the load side of the circuit. So as far as I can work out, and the way I understand things, to get any sort of voltage in there, we have to have a higher electron flow coming in than what we have going into the circuit. So once again the electrons are flowing out, going into the circuit, and then back out of the circuit through this cap, because they can't go that way, and driving this LED here. And we also have our potential difference from negative to negative, and that potential difference, which as we've seen 2.916 volts, is plus the battery voltage. It has to be, otherwise we would not be able to get the negative to go positive on this setup. So that's my little test on reversing the electron flow within this system, and as far as I understand it, I've done it correctly as someone mentioned to do, and it seems to be by all means working quite well. So that's it for me, and hope you guys that are replicating this out there can achieve the same results I am. This is why I've open sourced this, so it's not just a matter of taking someone's word for it. You can actually get out there and try it yourself and see for yourself. Cheers.